find our average value, we are going to have 1 over the length of the interval, so b minus a, and then integrate from a to b f of x dx. All right, so here my b is 2 pi, my a is 0, and then I'm integrating from 0 to 2 pi, the f of x function, which is cosine x dx. All right, so if I integrate cosine, I simply get sine of x, and then we go from 0 to 2 pi. Again, keep in mind, when you integrate, it's when you get a c function for your answer that you have a negative. All right, and then we have 1 over 2 pi as the 1 over the length of the interval. All right, so we're going to plug in the upper bound first. So we'll have sine of 2 pi minus the lower bound plugged in. And again, I'm not making a super big deal about the fact that I have to put brackets around this because it is just one term, so the brackets are optional. So we have 1 over 2 pi. Now if we think about our unit circle at 2 pi, we have a coordinate of 1 comma 0, so the y value is equal to 0. So this is going to become 0 here, and then sine of 0 will also be equal to 0. So you'll just have 1 over 2 pi times 0. So you'll get that the average value is equal to 0. All right, now for part B, what we have to do is we have to find the c value for which f of c is equal to the average value. So we will have 0 for our average value. Our f of x was cosine x, so our f of c is going to look like cosine c. So you look on your unit circle, where is cosine equal to 0 in that interval? Cosine is equal to 0 at pi over 2, but it's also equal to 0 at 3 pi over 2. And we're not adding the n pi here because our interval only goes from 0 to 2 pi. So we're just interested in the c value, the x values that are between 0 and 2 pi. So your c value is going to be pi over 2 and 3 pi over 2.